Hi folks, I'm Dr. Robin and I'm back for a new episode of K-Pop Science EDU. When I first started planning this lesson, I planned to mention how the K-pop world had been rocked by BTS announcing their military enlistment in the upcoming 2+ years. But then the Itaewon tragedy happened and the world was rocked by something much, much worse. I originally thought that perhaps I should change my topic because the stress response might be too closely related to the tragedy. But then I thought actually the stress response might be something that helped some of the survivors survive. So I intended to move forward with this topic with the intention of highlighting how powerful the human body can be. I originally chose this topic about the stress response because I was thinking about how being anxious affects our bodies. And K-pop idols in general deal with a lot of stress during performances and other activities. So to highlight this topic, I selected 2 clips that show how the stress response affected Jimin and Hobi in the last year or so. In the first clip, we'll see how Jimin was affected by the stress response while speaking at the UN in September 2021. And then in the second clip, we'll see what happened to Hobi while performing at the Grammys in April 2022.
온라인 공간에서 새로운 방식으로 친구들과 만남을 이어가고 새롭게 공부를 시작하고 또 앞으로의 새롭게 공부를 시작하고 더 건강하게 살아가기 위해 노력하시는 분들이 많습니다.
At the UN, Jimin lost his train of thought for a moment, paused, uttered a quick 죄송합니다, or I'm sorry, took a deep breath, and then continued on. At the Grammys, Hobi tripped on a step, almost fell, but didn't fall, caught himself, and finished his performance flawlessly. Now, I'm not pointing out these mistakes because they were a big deal, and in fact, probably most people who watched them didn't even notice. And certainly those of us who did notice quickly forgot about these little blips. But what I do think is interesting is how both of them later described how they were feeling at the time.
근데 그냥 한번 보려고 했는데 우리 그 페이지가 2번째 페이지고요.
긴장해서 안 넘긴 거지.
그래서 이렇게 넘겼는데 다음 페이지도 아니야. 한 번 더 넘겼는데 또 아니에요. 그래서 이렇게 웃은 거예요. 죄송합니다. 그리고 그 다음 1초 동안 제가 이제 대본을 연습했던 처음부터 끝까지 계속 다 했어요.
주마등
1초 만에 더 건강하게 그리고 땀이 뒷목이 그게 눈치채는지 모르겠지만 저 다리가 엄청 떨었어요. 저 하는데 이게 계속 안 멈추는 거예요.
호비 멋있었다. 호비
맞아.
호비 계단 올라가는 거 멋있었다. 사진이 있잖아. 야, 나 진짜로. 사실 지금 오늘 무대 너무 아쉽습니다. 제가 아쉬워하는 사람이에요. 아니 멋있었어. 와, 그 이후로 다리가 후들거리더라고. 나는 긴장을 해가지고. 시작 전에 긴장했었는데 호비 넘어지는 거 보자마자 바로 긴장 풀렸잖아.
In both cases, they described their legs shaking uncontrollably, and RM and Jimin both mentioned sweating. Now, I know most of us have not spoken at the UN or performed at the Grammys, but I'm sure all of us have experienced a time where a part of our body was shaking uncontrollably and/or we broke out in a cold sweat. I can't even imagine the poise needed to deal with these high-pressure situations because my mind went blank and my voice shook when I had to read off one name at a middle school award ceremony 2 years ago. So, the topic for today is, why does stress cause us to shake and sweat? This is a great way to learn about the nervous system. Our nervous system, which is made up of our brain, spinal cord, and a wide network of nerves, is used to send messages very quickly throughout our bodies. We have nerve cells that reach all parts of our bodies, and signals can quickly travel through them to and from our brain. Our nervous system has 2 major parts that control different important functions. One of these systems is called the somatic nervous system. This is the system of nerves that controls our voluntary movements. Voluntary movements are those that we are in control of and do on purpose. Voluntary. For example, I'm sitting here and purposefully moving my mouth so I can speak. If I stand up and sit down, raise my hand to scratch my face, these are all movements I'm doing on purpose and they're controlled by my somatic nervous system. If I want to open and close my hand, my brain decides open and close my hand, sends a signal through the somatic nervous system to my muscles in my hand, open and close. So the next time you watch some crazy synchronized K-pop dancing, you can say, whoa, their somatic nervous systems are really in sync. So to appreciate that, let's watch a clip from the live Run BTS performance at the Busan concert.
bulletproof, run, yeah, you got it, run, run, bulletproof, run, yeah, you got it, run, run, bulletproof, run. Okay, let's go. Woo!
So that is voluntary movement. On the other hand, where there's a whole lot of things happening in our body that we do not have to think about in order for them to happen. Our hearts beat, we breathe, we digest food, our pupils respond to light, we sweat, all without having to think about them. These things happen automatically and are controlled by our autonomic nervous system. So that name is nice because it is easy to remember that the autonomic nervous system is automatic. And the autonomic nervous system is what we have to thank for the stress response that makes us shake and sweat. Okay, so what does our autonomic nervous system do? There are two main parts to our autonomic nervous system. One part is called the parasympathetic system. The other part is the sympathetic system. The parasympathetic runs the show when things are calm and safe. The parasympathetic system is often referred to with the cute saying, rest and digest. In contrast, the sympathetic system is in charge of our response to stress and is associated with what you have heard called the fight or flight response. On this slide, you can see how they work together to keep us in balance. In this diagram, this is the brain and this is the spinal cord. The placement of these lines is representing where in the spinal cord the nerves connect that affect the organs on this list. Compare that to a diagram like this where you can see how nerves connect to the spinal cord down its entire length. The nerves that control these different activities do leave the spinal cord in specific spots, and the position generally makes sense with the nerves leading to the lungs and the heart leaving the spinal cord at a higher position than those leading to lower organs like our stomach and kidneys. When we are relaxed, our brain activates the parasympathetic system, and our bodies are calm. We are not on high alert, so our pupils constrict or get smaller. We don't need a lot of oxygen, so our airways constrict, and our heart rate slows. We can devote our body's resources to processes like digestion. Now this all changes when we are in a stressful situation and our sympathetic system ramps up. This activates our stress response that includes making things happen that will help us deal with the threat. Our pupils dilate or get bigger so we can see more. Our airways dilate or get bigger so we can get more oxygen, and our hearts beat faster so we can get that oxygen to important parts of our body quickly. In addition, processes we don't need during times of stress slow down so our body can devote resources to the important stuff. So processes like salivation and digestion are inhibited, and blood flow to our skin and extremities is reduced. All of this happens so we have the best chance of evaluating the danger we are in and responding to it. So what about the muscle shaking? Although it's not on that diagram, as you may guess now, during times of stress, the sympathetic system also activates a response in some of our muscles. This muscle activation is beyond our control and is not part of our voluntary movement. So if we're trying to stand still and give a speech at the UN or execute a precise dance at the Grammys, we end up with muscles shaking uncontrollably at some really inconvenient times. Now let's use this diagram to discuss why we break into cold sweats when we are really stressed or nervous. This diagram similarly uses a brain and spinal cord picture to show the general origins of the nerves reaching out to our body systems. As you can see here, in addition to the list of body systems the previous slide indicated were activated by the sympathetic system also stimulates sweat production. But why is it so often a cold sweat? Well, as mentioned briefly before, another thing the sympathetic nervous system does is to constrict or narrow the blood vessels in our skin. This is because during a stress response, it is more important for our bodies to have blood in our brain and important muscles. We don't need it as badly near our skin. So when the blood vessels near our skin constrict, less blood is sent there. The subsequent decrease of blood flow to our skin causes our skin to become cold. So during the stress response, we sweat, but our skin also gets colder, thereby leading to cold sweats. So when we are stressed, how does our sympathetic nervous system make all of these things happen all at once and so quickly? Well, our bodies are pretty amazing, so let's see how this works. First, when we detect that something is wrong, the emotion center in our brain called the amygdala sends a signal to our brain's control center, the hypothalamus. The hypothalamus then activates the sympathetic nervous system and sends an electrical signal down our spinal cord. Many of the nerves in the sympathetic nervous system directly reach our different body systems and release norepinephrine, or NE, as a signal to those systems that they should respond accordingly. The other main thing that happens is that sympathetic nerves reach the adrenal gland and signal the adrenal gland to release more norepinephrine and epinephrine into the blood. The norepinephrine and epinephrine then travel in the blood to the different body systems to signal that they should respond accordingly. When they reach the heart, they cause the heart to beat more quickly. When they reach our eyes, they cause our pupils to dilate. And when they reach our skeletal muscle, they increase muscle performance. Now, epinephrine has another name, adrenaline. So this is why you have likely heard phrases like adrenaline rush, or that really got my adrenaline pumping. Adrenaline is the major factor used by the sympathetic nervous system to activate the stress response. Now, interestingly, you probably have also heard of EpiPens. EpiPens are used to inject epinephrine to counteract an acute allergic reaction. So what I think is really interesting is that both terms, epinephrine and adrenaline, are used commonly in our everyday language. However, I'm not sure that most people realize that they're the same thing. Now, the nerves from the parasympathetic system also reach many of the same body systems, but it has to activate a different response. In order to do this, the parasympathetic nerves release a different signal called acetylcholine, or ACH. So when our body systems receive the acetylcholine signal, they respond as per their rest and digest protocol. Now, how can your body systems tell if they are receiving the sympathetic signals of norepinephrine and adrenaline, or the parasympathetic signal of acetylcholine? It turns out that the cells in those organs and systems have receptors on their surface that can tell what is floating by. Here's what that looks like. If we zoom in on an organ like our skin, we can see that it is made up of cells connected together into sheets of tissue. Each of these cells is surrounded by a membrane that has receptors that allow it to respond to the environment around it. So if adrenaline floats by and bumps into the cell responds one way. If acetylcholine floats by and bumps into the cell responds another way. Here is a look at some of the receptors in skin cells. The AR receptors are the receptors that respond to adrenaline and norepinephrine. The M receptors are the receptors that respond to acetylcholine. And here is an example of the different reactions that can occur after a receptor is activated. Here, the AR receptor activates a reaction. Here, the M receptor inhibits a reaction. Now note this letter beta in front of the AR. Many of the receptors that respond to adrenaline and norepinephrine are called beta receptors. You may have heard about drugs called beta blockers that can be used to calm our bodies during times of anxiety and stress. These drugs are called beta blockers because they block these beta receptors. If those receptors are blocked, adrenaline and norepinephrine cannot bind to them to cause all those chemical reactions that rile everything up. I have a friend who has been so anxious while giving presentations for audiences that she has fainted. So she has been prescribed a beta blocker that she can use in times of high anxiety to decrease the effect of the stress response on her body. This reminded me that before emceeing the 2018 KBS Song Festival, Jin took some Cheng P in an effort to calm himself.
다 먹었다가 너무 차분해져가지고 못하면 어떡해요? 2018 KBS 가요대 축제에 오신 여러분들을 환영합니다. 이러면 어떡해요? 안 그럴 것 같아. 8시 15분. 담아갈래? 액체로 된 것도 있던데. 맞아요, 요새 액체로 된 거 있던데. 진짜 다 먹어요? 먹어. 네? 네. 야, 데뷔가 6년 차인데 이제 방송 덥다고 점심을 먹고 있네. 근데 이제 뭔가 처지는 기분이다 벌써. 그래서 마음이 가라앉고 막 벌써 약도 먹는 것 같아요. 한번 진짜 팍 할 수 있었는데.
I don't know anything about Cheng P other than it is a traditional Korean herbal medicine. And from the information I could find in English, it doesn't look like there is necessarily a set recipe for the medicine. However, I did find a patent in Google Patent that listed some potential components. So I searched to see if any of them had been tested for being a beta blocker. Now, I didn't find anything, but I did find a 2021 paper by Zheng and colleagues that reported that a substance extracted from one of the medicinal herbs mentioned binds to a type of beta receptor. So that got me thinking. Perhaps some of the traditional medicines used for calming have components that are beta blockers, or that otherwise reduce the effects of the sympathetic nervous system. It looks like the research is ongoing, so we may learn more about this soon. And that is it for today. Let me know if you have any questions or suggestions. I will see you next time. Until then, keep listening and keep learning. 감사합니다.